Okay, today is Tuesday, October 20th, and we are talking about systems of inequalities, okay, linear inequalities, okay. Now, we've done some things. We worked with systems of equations where we had to actually graph the equations and find out where the intersection point happened. Yesterday, you worked on section 3.2, which was doing it algebraically. Now we're going to go back to inequalities, and unfortunately we can't do this algebraically, so we're going to have to end up doing this graphically. And what we'll do is we'll show you. This is all leading up to linear programming. Huge topic. Takes us a few days for us to do. It's a big one. Don't forget you have a quiz. I think that if you're in the B section, I don't think your quiz is Wednesday. I think it ends up to be Friday. We'll double check that to make sure. But if you are in class, then it's going to be, if you're an A-Day student, you have a quiz on Wednesday. So going through and doing this. Now, it's very much the same. We've done a lot of this. We're just going to add one thing to this. So the first thing I'm going to do with this very first one, I'm going to go down 3, put a dot. Up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Dash line. I'm sorry, it takes me so long to get those lines all matched up and everything. I'm just going to do this by paper here. And I'm free-handed. So now I choose this point. This makes this my yes side. This makes my no. So I'm going to put a 0 in for the y. 1/2 times 0 minus 3. So 0 is less than -3. That's a big no. I'm going to lightly controlled shading on this one. Now I'm going to do the next one, and I'm going to use a different color pen for this one. Okay, so y is equal to, so here we go. Y is greater than or equal to -x plus 2. So at 2 I put a dot. -x, so down 1, right 1, down 1, right 1, down 1, right 1. Lots of targets here for me to hit, so that I can draw a straighter line. That's not too good either. Okay, now here's my point. This is my yes side. This is my no side. Now, when I do this, and I'll put the 0, 0 in there. So 0 is greater than or equal to -0 plus 2. So 0 is bigger than or equal to 2. So now I'm going to shade this one. I'm going to, again, control my shading a lot for this. This end, I did it all backwards. So I better start getting rid of those things. Let's see how to do that. Undo. There we go. And let's try that again. Undo. Okay. So is 0 greater than 2? No, it's not. Right, so I'm going to shade this way. Again, I want to control my shading. Now, here's where the rubber meets the road here for this one. Now, I want to find where are both these true. So I have region 1 here, 2 here, 3 is right here in this corner, and 4 is here. And the question comes, where are they both true? Well, obviously, region 1 just doesn't make sense. So I'm going to use the highlighter here. So region 1 doesn't make sense. That's not it. Region 2, this region right here, there's only one shading. Region 3, I have both shading. So this looks good to me. Down here, only one. So that's my region that I know. Region 3 happened to be the magic region for this particular one. That was the one I wanted. Now, notice this is the same thing that we've been doing. We add one step because we have 2 of them on here. We're looking to see where both of them are shaded. Where does it overlap? Where does it not? That's what I'm looking for this. So this one, okay, we'll start off with this one in black again. -2, put a dot. Up 2, left 1, or down 2, right 1. solid line. So I'm going to draw a nice solid line as best I can here. I'm excited about my shading. Yes side of this, no side. So 0 greater than or equal to 0 minus 3. Is 0 bigger than or equal to negative 3? Well, it's bigger than. So that's a true statement. So I'm going to shade the yes side. Again, I'm kind of selective about my shading. I don't go all crazy like I was before. Now, this one is in red. Now, I can change this to slope intercept form, but man, notice how the 3 plays nice to the 15. So that means if I put a 5 in here for y, I get this. So at 5, 0, I'm going to go here. Then I notice if I put a negative 3 in here for the x, then I get a 0. I get 15. So there they are. Dash line between these two. The yes side, the no side is 0 minus 0 less than 15. That's a yes. All right, and this is my red line, so I'm going to shade the red way. All right, now at this point, now comes the hard part. Which region is it? Is it region 1, which is all this? Or is it region 2? Is it region 3? Or is it region 4? Where they both overlap? Well, 3 is not it. That's easy. 4 only has a black through here, and 2 only has that. So that tells me that my region that I should go nuts with is this right here, because it's shaded in both. Now, again, remember, we're just going one step further. Got the 2 of them down there. We got to decide which one's which. I like to number the regions just so that I make sure I know. And those regions are separated by the lines. There's that region. Here's this region. Here's this region. And there that one is. Special cases. There's always got to be something special. So let's see here. Let's do this first one. You go over 4 per that, up to 1. Can't run out of room. Down to. Keep going here. There they are. Dash line. Yes side, no side. 0 bigger than 0 plus 4. Is 0 greater than 4? That's a big no, so I'm going to shade this way. Do the other one. Hey, those numbers look like they work. They play kind of nice. They seem to like each other. So doing this one in red. So let's put a 0 in for the x. What do I need to multiply 4 by to get negative 12? I believe that's negative 3, so that's a y-intercept of negative 3. And this other one, oh my, that doesn't work out very well at all. Because 8 won't go into 12. This is a bad choice to do it this way. So let's solve this one for y. Okay, the first step I gotta do is I gotta get that x over there. And then I'm gonna divide everything by 4. So minus 3. Oh, right now I see a lot of things here. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. Down to 1. Solid line. Now, my graphs don't look like it, but my equations sure like they have the same slope. Let's try the 0, 0. So now this side is my yes side, and this side is my no side. So 0 minus 0 less than negative 12. That's a big no, so we shade this way. Now, looking at this, where do they overlap? Where does the shading overlap? Well, this one goes here, and this one goes there. This particular one has no solution. Those two lines are parallel, and they don't intersect. The shading goes opposite each other. There's nothing that they share. It has to share. Okay, now let's say we have another one. And this one I got all done for us, so we'll have to figure this out. So go up 4, put a dot, and then up 2 over 1 or down 2 over 1. So there's those points. Okay, special case, 0 in there, 0 in there. Is 0 smaller than 4? It sure is. 0 is smaller than 4, so I'm going to shade this one. This one, 4, 2, oh, there's this exact same line. Let's put a 0 in for this. Is 0 bigger than 4? It's a no, so it shades this way. So where do they overlap? Only on the line, because both of them are equal to. So the only ones that work is the points on that line. Now you will get some like this, and maybe one of them's dash or whatever, but they won't intersect. Okay, so it will be a no solution. You'll also get some that, let's say this equation happened to have the other way, that I'm shading the same way for both of them, then I end up with all those numbers. Sometimes even they shade one shades this way, the other one shades this way, they overlap, everything gets done. Like on this particular one, yeah, the only one that works is here, but sometimes it works out that you get both. Different problems there, special problems here. Now, let's warm up here. This is good. We got to stretch out a little bit here. A charity is selling adult t-shirts for $15 and student t-shirts for $10. Charity needs to raise at least $3,000 and only has 250 t-shirts. So we're looking for a quantity. Hey, if I misspelled that, that's too bad. And a cost. I also call this a value equation. Okay, those are two types of equations I'm looking for. Let's decide what's X. I'm going to have X be the selling adult t-shirts and student t-shirts. I'm going to have X be number of adult t-shirts. Y is going to be the number of student t-shirts. Okay, quantity. How many t-shirts do they have to sell? They only have 250, but could they sell less than that? They could. Okay, so there's that first equation. Now, what about the second one? Cost or value? Well, it costs $15 for an adult ticket, and it costs $10 for a student ticket. And they need to raise at least $3,000, so they could raise more. And there's my two equations. This is where we want to stop. We want to get these two equations written down. Now, from here, I could go ahead and graph this. Okay, 0, 250, and 250, 0. So if I wanted to think about this, this is 250, and this is 250, and I draw that way. Okay, it would go, okay, so 0 plus 0 is less than, that's true, so it would go towards the middle. This one, I divide 1,500 into there, and so this one's 300, and this one's 200. So these two things go like this, and we want to be able to make as much money as we can. So where do they share? This little bit right here. Just in there, and that's where they overlap here. This is where we're going. You have to be able to write it out first. Oh, the graph paper, sorry, I could have done right there. And there you go. That's your assignment for today. Make sure that you graph these out. Graph paper is needed and required here. See if you can maybe print this off. If you can't print it off, then see if you can find some graph paper. Either you can go and buy some, or you can print some off just off the online, because there are some. I do happen to have some in my classroom, but obviously you're not here, so that's not going to work for us. So we'll have ourselves a good day, and we'll see you guys on Thursday.